Hi there. I recently bought a Blade 200 SRX helicopter and I thought I would enhance it with some a nose light and red and green navigation lights, which I hope you can see flashing there. The project was an interesting one. It required a number of things: sourcing the bulbs, working out resistance, and I just found it interesting, and I hope that what I've learnt I can pass on to those who might be interested in following the same project. Now, at some stage you're going to need to check the output voltage of the receiver, and the way to do this is to take some form of electrical test meter. I've got a cheap and cheerful one here, and with the two leads, just touch the positive and negative and see the reading. This is going to be a bit difficult to do because I want you to see the voltage reading, hopefully. Can you see that? That's showing 5 volts. So I know my output voltage is 5, and that's important when looking at the other navigation lights in particular, because we've got to make sure that we've got the right resistor. So that's 5 volts, and it's the same if I touch the other one too. It's 5 volts, and because it's quite a tricky operation, just take it as read that the one over here is also 5 volts.
Okie dokie. So now that we know what our voltage is, we need to look for a suitable bulb. I've chosen 3mm size, as I think it's about the right sort of size. It looks okay on the aircraft, and you can find these on eBay. They're very cheap in UK, £1.79 for 10, as you can see, 10 here. Now the nice thing about this, and it comes in green, I won't bother showing you that page, but if you scroll down you get all the details you need, really. Apart from the size here, you can see it does show the forward voltage, which we're going to need, and the forward current, two very important. So we know that the source voltage is 5 volts, and we now know that the forward voltage and the forward current are 1.8 to 2.2 and 20 milliamps. So all we now need to do is to find out what resistor we require in the circuit. Okay, as I mentioned just now, let's move on to see what resistor we require to fit into our circuit. I've used this website, which I find very helpful, led.linear1.org, and this is the page that comes up, and it will give you the answer that you're seeking for. So let's just fill in the blanks and see what we get. We know our source voltage is 5, so we put 5 in. We know the diode voltage, the diode forward voltage was 1.8 to 2.2, so we'll call that 2. And the forward current was 20 milliamps, so put in 20 there, and just let the calculation decide which one, and there you have it. 150 ohm resistor in circuit on the positive side, running through to the LED bulb there, which is running on 2 volts. Okay, I hope you found that helpful. We'll move on to the next stage in a mo.
We'll now move on to the next part of the project, which is to construct the flashing lamp from the components that we've already purchased. Here's the servo lead, which we'll obviously need, the bulb, the 3mm flashing red bulb that is, and the very small 150 ohm resistor, which we know from our previous calculation was required. I like to test the bulbs first before I go through the construction, just to make sure that they work. Let's see, there we go, and hopefully you can see that flashing. So I know this is a good bulb. Right, we don't need this complete length, otherwise it'd just be too much dragging behind the helicopter. We need about 4 inches or 10 centimeters, and I've already prepared the length here. So I've basically cut that down to size and put the rest away. Now it's the fiddly job of getting the white lead, which we don't need, from the connection. Take a very small screwdriver and you can prise open. There's a little black tab here that holds the pin in place. And if you just gently ease that up, and it allows the white, see the white one come out, and you can just strip it away as we don't need it. So we end up with the female part and the red and black connections, and the connector goes into our power source, which you know is 5 volts. Now you'll be able to see that I've cut this wire by about another centimetre. It's about 9 centimetres, and you can see that I've already trimmed off the silicone cover coating over the leads. What I'm now going to do is to cut a little bit off the resistor, as I don't need these long bits, and so take about that amount off, I would think. And the same on the other side. You can probably go a little bit less than that if you want. So there you have it. So that's down. So that's down to quite a small size in length. The other thing I'm going to do is to shorten the contacts here on this bulb. And again, you can be quite brutal with this. But remember, I always cut diagonally, so I know which is the positive and which is the negative. So if I make a small cut, and you need a little bit here because the bulb is going to have to bend through 90 degrees. So that's what we end up with, something like that. And now we'll get on with the soldering and the connection. What I should have mentioned, I don't think I made it clear a moment ago, is that when you're sizing the wires, cutting to the length, you've obviously got the one long wire, which is going to be about 9 centimetres, 3.5 inches. So, but because you've got to fit the resistor in series on the red wire, you need to allow for that, otherwise you're going to get a kink. So I don't know if you can see this well. You can see here how the resistor is going to fill the gap. So work out the size or the length of the resistor with its wires, and then make the red lead a little shorter appropriately. Right, now we get on to the interesting part, the soldering of the resistor onto the positive side of our power outlet. Helping hands, absolutely essential. There's no way I could do this without helping hands. Let's just see how we go. It might be a bit difficult to see this, but let's give it a little while. There we go. And the other thing, I've got the heat shrink on, you can see here. So it'll all be covered up when we finish. So that's one side done, and the other side will be done in exactly the same fashion. So you can see we've got a nice good joint there. So I won't bother showing you the other side. We'll just get onto the heat shrink in a minute. So there you have it, the two wires connected to the resistor and the bulb, and the negative, the black one. And with the heat shrink, it's just a matter of putting that, easing these over the top. They are, and I'll get my heat gun out and shrink those. Now there's one final thing that I like to do before I install the finished product onto my helicopter, is to make sure that it's still working and that the connections that we've soldered are in fact as good as we hope they would be. And this is where you can bring in the other half of the piece of wire, the servo wire, lead that you cut in half, and if we reconnect these two, or connect these two, and then from a suitable power source power it up and see what happens. And keep your fingers crossed. And there you go, turn out the light, and there you have it, our flashing 3mm LED bulb. So having made the red flashing navigation light, I've now attached it to the helicopter, and what I've done is from the power outlet, which is the back of the receiver, I've got the wire coming here, and part of the frame I've just squeezed it in between. It's not forcing it, it will sit in nicely, and with some heat shrink provides a degree of rigidity in there. And the same with the green light as well. It's fitted behind this support beam here, so it's in between that and the receiver, and this is connected to the one of the other 3 outlets on the receiver. And there's the finished product. Nose light and 2 navigation lights on my Blade 200 SRX helicopter. I've enjoyed doing the project, and I hope you've been able to follow me through it stage by stage. I think it makes a great improvement on the look of the helicopter, and certainly enhances its look in dusk and low light conditions, as you can see here. So thanks for watching, and good luck if you try and follow suit. Maybe see you again sometime on a future project. Thanks, bye for now.